3.4 comparing measure of center. So now in this section, we're going to talk about outliers, which are extremely large or extremely small observations relative to the book of the data. So the effect of outliers on the measure could be affected by outliers which is influenced or sensitive to the outlier, something like mean, standard deviation, or the range. So they are used in bell shape, such as unimodal symmetry, right? And then with no outliers for that. For the one that's not affected by outlier, okay, so we is like we use the word as a resistance to outlier. It's going to be medians IQR. So they use on skew distribution or bell shape with outlier. Yeah. So how to handle the outlier? First, we need to check if the outlier is a mistake, right? Check it mistake, right? And if it's a mistake, correct it. Okay? If it's not mistake, choose the medians at the center. So let's take a look at examples 1 below here and see what happened. So in here it is Supreme Court just in 2017, and you can take a look at the years appointed and the years of service in 2017. You can see there's most of them is about like 20 somethings or 10. I mean around like from 0 to 20 something. But look, there is a case with 49 from Kennedy, and that could be like a outlier. But let's see what happened. Why? Is that a mistake, right? You see that years apart was a 1,988, and the year of service in 2017 is 49. Well, does that make sense? You can check by using 2017 minus for 1988, and you see that what is that going to be? It's going to be in 29, right? So this is a mistake from a reporter, right? Mistakes. So I mean, if you know that is a mistake, you need to, fix that, change that 49 to be 29 instead of just leave it like that, right? So let's describe the distribution of years of service by giving the shape. So the shape will be school, right? School, right? And for that, the number for the numerical values for an appropriate measure of centers for this, I would say minute, right? Okay. Okay, so keep in mind that this is school because you can see that it's school to the right. It just come from the big number 20, say 29, 26, 24, 23, and then go down to 0. So that's school to the right. and then and the numerical values for an appropriate measure for the spread. Because this is school, so you will use what do you think? IQR, right? Okay. And is there any area? Clearly, it was 49 years, right? And it's just I can say extremely large. Extremely large. Okay, extremely large value. What else? So that will make the mean is larger. As you make the mean is larger. Okay. So how do the mean and median compare for this data? Well, the mean must be greater than the median because the school to the right. So so that's make the mean is greater than the median. All right, so let's okay, so let's move down. If we change the shape to be symmetric, right? Change the shape. I mean, in this case, we know that there was an error, and just that Kennedy has served 29 years, not to 49 years, right? So if you correct this with the new data, what happened, right? I mean, the shape now gonna be symmetric. Yeah. And the numerical values for an appropriate measure centers in this case will be the mean. Clearly, if you have symmetric, and the spread will be standard deviation. And any other? No, you don't have anyone else. In this case, the mean roughly will be equal to median, right? I will use approximately. Okay. So let's move down and see that. The idea is if the shape is bimodal, okay, if the shape is bimodal, let's highlight. Then the mean and the median do not represent the typical value. Okay, so this is watch out. If it's bimodal, you mean and median do not represent it. Rather, if the data is created by two subpopulation, then separate them and look at the shape center and spread of each subpopulation distribution separately. So as you see in example 2 here, a restaurant that serves both lunch and dinner combines all of its receipts together, create the following graph over here. Notice there are two typical values, but neither are described by mean or median. Okay, so center equal to typically in this case. So centers center. Let me time it better. So center in this one could be medians and mean is also a typical for the distribution here. Okay, so and if the data separate out by lunch customer and dinner customer, we can better describe the distribution. Displaying the data with 2 histogram also allows for a comparison between lunch and dinner customer. So let's take a look at this below here. All right, and you see if I separate out the lunch and the dinner, I have 2 graphs, okay, and you can see you can see that the first one is for the lunch and the second one is for dinner, and we can compare and contrast the distribution of receipt for lunch and dinner, such as the shape, the center, and the spread. Okay, so for the shape of the lunch, what is that? Okay, so take a look at the shape of the lunch. I would say roughly symmetric. Yeah. For the dinner, clearly it's school to the right. Yeah, so the idea, I mean, when we're comparing group and one group is the school. Then compare the medians and IQR for our group. All right. So the center is a median of lunch received. It's gonna be, what's that? I think it's about $8.50. Let's say that. Is less than the dinner, about 20, say 22, I think. Yeah. The dinner. And the lunch receipts are typically so the lunch receipt are typically less than dinner receipt, right? Less than dinner receipt. Yeah, because of median here. So the spread for compares the spread, we're gonna compare the IQR, right, of the lunch and dinner receipt. So I will stop. This is 3.4. We just finished this, and I'm gonna stop the video here. We'll see you in the next video for 3.5.